I will discuss linear relations. Now, linear relations have a technical math definition. And the definition is simply this. Change. It's not. Still blue? Oh, it's just behind. Oh, yeah, it'll catch up. Change to the IV results in predictable and constant, is it there yet? And constant change to the dV. That's the mathy definition. In reality, it means this. The graph is a straight line. Okay? Don't draw right what I'm about to draw. Okay? Last year you saw something like this. Right? And that had an X and a Y value, yes? And as you moved along the x-axis, plus X, you moved up Y, all the way along, right? Every change in X, if I went over 1, I went up 2, 1, 2, 1, 2, that makes a linear relation, okay? If I went over 1 and up 2, then if I go over 2, I would go up 4. If I went over 3, I would go up 6. Everybody with me? That's what makes it a line. That's what I mean by changing the IV. Any change results in the same change to the dV, which gives you a straight line. Everybody cool? That's grade 9. Now, let's use it in grade 10 right now. Pizza Hut, which I hate. I know. Well, they're old notes. What do you want from me? Pizza Hut charges $12 for an extra large cheese pizza. The worst kind of pizza. No, cheese is the worst kind of pizza. Cheese is what you order when a bunch of people can't agree. Fine, we'll just get cheese. Because nobody can agree on pizza. Because some of you clowns like ham and pineapple. No, it's disgusting. You would rather have cheese. Ham and pineapple is gross. I put fruit on a pizza. Stupid. Hate ham and pineapple. Although, guys, something weird happened to me. I was at a kid's birthday party, and of course kids are stupid. The only thing they like is cheese or ham and pineapple. And the only thing left was ham and pineapple. And I was like, that's gross. I don't want it. And my wife said, you're being an idiot. Just pick off the pineapple. Because my wife still likes ham and pineapple, but she never gets it because me and my kids hate it. So my wife said, just pick off the pineapple. Fine! So I picked off all the pineapple, ate the pizza. Loved it. Loved the little bit of flavor from the pineapple. Hate the actual pineapple. Which is weird because if I have a fresh pineapple, I will eat that thing like an apple. Can't get enough of it. But tin pineapple, bleh.
Or just warm pineapple.
Yeah, I know, warm pineapple, barf. You know those people that grill it and put it in like food? Oh! Grody. I even have this cool thing that's like a giant corkscrew that drills out the pineapple. And you get one long spiral of pineapple, and it leaves the core in the shell. And then if you break off the core, you can use the shell like a cup.
You know, like in Japan, you can get a squid ink pizza. It's basically like cheese, but the cheese is replaced by squid ink.
Yes, I've heard of squid ink pizza.
Squid ink pizza.
Yes.
How is
Squid ink, there's squid ink pasta too. It's black. Squid ink. Because squid, when they're scared, they pee out ink. And it makes the, like an octopus. Octopus do it too. Calamari is squid. If any of you like calamari and didn't know calamari is squid, now you know. Calamari is delicious. Yeah. It's disgusting to prepare. You can't eat the tentacly ones, you can only eat the rings. Tentacle ones are easy to prepare, the rings are the pain, because that's the long part of the squid, and inside it is still its skeleton. So when you get them, you have to reach in and pull out the skeleton, but it's not bones. It's like clear plastic. And if you forget to pull it out and you cut it up, then people eat it. They get chunks of that in their food, and it can like cut up their insides. Or so I've been told. I don't know if it's true. But yeah, you got to reach in and pull out the guts. And then you cut it up into rings. Then you put it in flour with seasoning, and then you deep fry it, and then you serve it with tzatziki. Delicious. Okay, so draw a graph to represent the cost as a relation to the number of toppings. So first thing we got to decide is what is our DV and what is our IV? You just said them both, Mark. Which is it?
The second one.
The second one. The DV is cost. So the IV is toppings. Why?
Because the cost of the pizza depends on how many toppings you have.
Yes, how much you pay for the pizza depends on the amount of toppings. Right? So what goes on the x-axis? Cost or toppings? Toppings. Because it's the independent variable. Now, how will I put the scale on here? What is the least amount of toppings I can order on a pizza? And cheese does not count. Zero. So I'm going to start at 0 toppings, which would be cheese.
$12.
What's the next one? 1. What's the next one? 2. What's the next one? 3. What's the next one? 4. Cool? Now, stop and think for a second. Done. I just told you to stop and think, but I didn't tell you what to think about. I just wanted you to think. First, it doesn't matter. Just think.
You got me there.
I know. And this is cost. Now, what is the cheapest pizza I can buy? Cheese, right? So what's the lowest value I need on my cost? 12. The pizza goes up by what? $1.50. So I'm going to go 15, 18, 21. Is everybody cool with that? All right. Where does my first dot go? At 12, but that's only half. You're right. There's my first dot because 0 toppings is $12. Yeah? Yeah. Now, how much is a 1 topping pizza? $13.50. So, what did I just do? I went this way 1, and I went up how much? 1.5. Everybody cool? Where's the next one going to be? 2.15, right? And I went this way how far? 1, and I went up how far? 1.5. Where's 3 going to be? 16.50, yeah? 4.18. Everybody cool? Everybody understand? Yeah? Yeah? Okay, so now I have to ask you a couple of questions. Question 1. Is it a linear relation? Oops, not relations, it's only 1. Is it a linear relation? Yes or no? Yes. Why? Right. 1 left, 1.5 up. Every single time. Right? That's question 1 I have to ask. Question 2. Is it discrete or is it continuous? It is discrete. Why? You can't put on half a topping. No, you can put half the pizza. They charge you the topping. Call up Panagopoulos and say, on a cheese pizza, I want to add pepperoni, but only on half. Okay, that's...
But then
Yes, but they don't charge you $1.50. They charge you the $2 extra. Right? You still pay for all the pepperoni, which is why you always need to say, put all the pepperoni you would put on normally, but only on half the pizza. Because if you don't, they will cheap you out, and they will only cover the pizza with half the proper amount of pepperoni. I have brought pizzas back for that. Because I work in food, and I know what you did. And they're like, I didn't do that. And I'm like, I'm looking at a pizza right there that you're making with pepperoni. I can count. It's like 40 slices on there. I got 20. You charged me for a full amount. I want my 20 more slices. And it's an open kitchen, so you can't spit in my food. Next time, count, moron. I don't say moron. Well, that's what you do. You vote with your wallet. You just stop buying food from those people. All right. Everybody good? Everybody good? Everybody understands? I cannot draw this line, can I? Because if I draw this line right here, then that says I could put on 3.5 toppings and it would cost me something between $16.50 and $18. And that is not possible, is it? Excellent. You guys are so smart. Don't let anybody tell you different. Am I recording? Good. All right. Next thing you need to be aware of. Linear relations or linear functions. But I'm saying relations because that covers everything. Excuse me. Have 4 manifestations. You don't have to write manifestations. I just like using that word. I'm spelling it wrong. Manifestations. 1 is the graph, which you have just made. That is one way to show a linear relation. Okay? 2 is with words, which we have up at the top, right? That's the question that we just graphed. Everybody cool with that? Right? And there's lots of examples of that. Now, there are 2 other mathematical ways to describe linear relations. The third is a table of values. Now, a great many of you will call this a T-chart. I don't know why. It's a table of values. Somebody invented calling it T-charts because they felt it was easier than saying table of values. But that's like calling Mark John, because Mark is easy. John is an easier name to remember. You don't need to give something a new name. Anyway, the table of values is always written as IV dV. In grade 9, you wrote it as X, Y. But now we put our IV and our dV on in that order. Okay? So what goes over here? Our IV, which in this case was toppings, and over here was cost. 0 toppings, $12. 1 topping, $13.50. 2 toppings, $15. 3 toppings, $16.50. And so on, right? If it is a linear relation, 1.5, 1.5, 1.5, 1, 1, 1. Every change here makes the same change here. Now here is something that will screw you guys up. What if I go to 5 here? I have now jumped 2, yes? A bunch of that just disappeared. So what would be here? 1950, which is a jump of 3, because I jumped 2 there, so I double this jump. Does everybody understand? It's still a linear relation, okay? Even if I erase the ones in the middle, that is still a linear relation because I went up by 2, so I went up by 3. I did that poorly. But you understand what I'm saying, yes? It doesn't have to be 1, 1, 1. As long as the changes are the same every time. Everybody good? Yeah? Okay. Now the last way you can do it is an equation, which is what you ended up with in grade 9, I hope. That would have been the last thing you did in grade 9 linear relations. You would have done this. All right. I had toppings, I had cost. 0, 12. 1, 13, 50. 2, 15. 3, 16, 50. And somebody said, okay, now make an equation. Now, you guys are smart kids. Hopefully, your teacher last year told you that equations are always this. Your dependent variable equals, because it depends on what happens to your independent variable, right? Your dependent variable equals your independent variable with some math. Some math happens to your independent variable to get you a dependent variable, right? So what is our dependent variable here? Cost. So our cost equals our independent variable, which is what? T for toppings. I'll make it a capital T. No, I'll make it a small t. T for toppings with some math, yes? Everyone agrees? Okay. What math is happening here? Add 150, right? So this first thing here, when it was 0 toppings, it was $12, yeah? So could I not write this as $12 plus 150? Does everyone agree? That's the topping, right? At my second topping, do I pay that original $12? Yeah. And I add $1.50 and another $1.50. What's the short way that math guys write 150 plus 150? 150 times 2, correct? What's this one going to be? 12 plus 150 times 3. What's the next one going to be? 12 plus 150 times 4, right? What is it going to be if I have an unknown amount of toppings? Do I pay the original 12? Yeah. Plus 150 times what? Not x, t. So now I have an equation, don't I? Do I have some math happening to my independent variable? Right. So my cost is going to be 150 times t plus how much? 12. Everybody got it? Now here's something that messes you guys up. You don't necessarily recognize that 12 plus 150t is the same thing. You need to recognize that. Does everybody recognize that? It's got the same stuff, yeah? Everybody cool? Cool? Okay. So, I remind you again, a linear relations are relations in which two variables, what are those two variables? X and Y, IV, DV, input, output, all the names we've given for it, yes? I'm going to say IV and DV and all their other names, relations in which two variables, input or independent variable and dependent variable, in which two variables have sets of data that show constant, predictable change. Now, I've written that twice because it's important. Now, what does that mean in English? it means this. X, Y. The next dot is at the same X and Y. What if I'm going downwards, which is the thing that screws kids up? This is all positive. Well, there's 0. What's happening this way? Minus X and minus Y. But they're going to be the same amount of magnitude. Do you understand? Relations. It's short for relations. It's just shorthand that I use. So where's the next one going to be going this way? Negative X and negative Y. And it will continue onwards. Is everybody good? Now the next thing that messes kids up is this. Does a linear relation need a line? No. Don't be fooled. Is this a linear relation? Yes, because we went over and up the same amount all the way. There's no line. Okay? Everybody with me? Now what about this? I'm going to show just another graph. You don't need to draw it. Is this a linear relation? Has a line. Pardon? Yeah, it's not equal, is it? Here is flat. And then I went over a little and up far. Then I went flat. Then over a little and up really far. Then flat. Then I went down. So that is not linear, even though it's got a line. Everybody with me? What about this one? Is this linear? It's got a line. It's not constant, right? Because here I'm only going a little, I go really far over to go up a little, right? And then all of a sudden I go over a little and I'm going way up. Everybody good? Okay, let's make sure. Turn the page over. I think your guys is printed correctly and mine is poopy. You should have 2 charts, one with Celsius and Fahrenheit and one with I and P. You have both, yes? Okay. The Celsius and Fahrenheit one, if you would be so kind as to tell me the next couple, please.
For Celsius?
Oops. Yeah.
For Celsius, it's 0, 5, 10, 15.
0, 5, 10, 15.
And for Fahrenheit, it's 32, 41, 50, 59.
50, 59. Yes? Okay, screw you. 10. Fine, we'll do it this way. You want a piece of me? 10. And what was the next one with 10? 50?
No, it was 32, 41.
What's after 41? 50, and then 15 and 59, right? Yeah, you damn Skippy. What did I go up by here? 32 to 41. Plus 9. What about here? Plus 9. What about here? Plus 9. What about here? Plus 5. What about here? Plus 5. What about here? Plus 5. Is it linear? Yes or no? Yes. How do you know? Yeah. X plus 5 got Y plus 9 every single time. So it makes a line. This is one way to show a linear relation. Cool? Now the next one that you guys have was I and P or something. Does it matter what I and P stand for? No, of course not. Who cares? It's ignoramuses and potatoes. Yes. For every, what's the first one? Give me all the I's.
0, 5, 10, 15.
0, 5, 10, 15. And give me all the P's.
0, 75, 3,000, 6,750.
5, 5, 5. All the same, yes? 75. 2,925. Are they the same? No. So this guy is not linear. Easy peasy lemon squeezy when you have a chart, yeah? Right? Easy, right? Okay, let's look at C. Is that a chart? No. Can we make it a chart? Sure we can. What would be on our chart? I and P, Q and Z. What? X and Y. X goes first. X is the input. What number do you want to input? Who's in charge of what number you input? You are. Antonio says 2. So now X is 2. So what do I write right there? 2. So I have 2 times 2 plus 4. What is that? What's 2 times 2? Plus 4. So when X is 2, Y is 8, yeah? I'm going to do something really crazy here. I'm going to put in 0. Mr. Myers, you're going downwards. You crazy? Ooh, doggy! So what's it going to be? 4, because 2 times 0 is 0 plus 4 is 4. What would be the smart next number to input? -2. Because I want to keep this the same, don't I? Which would make it? -2 times 2 is -4, right? Plus 4 is 0. So let's check. What happened here? -4. What happened here? -4. Is it the same both times? Oh, yeah. Yes. Because when X was -2, Y was -4. Every time. Now, you guys are smart kids. What if I'd gone the other way? It would be X plus 2 and Y plus 4. Yay! Now, what's this one? X, Y. What would be a good number to start with? Let's use 2 again. Okay. What's 2 squared? 4. What's 4 times 4? 16. What's 16 minus 1? 15. Cool? Okay. What's 0? What's 0 squared? Times 4. Minus 1. -1. Yeah, I fooled you there with that tricky question of 0 minus 1. Mr. Myers, you got a lot of nerve throwing curveballs like that into it. Subtracting? One number? Whew. All right, now, if this is linear, what would -2 be? -17, right? Well, let's check. What's -2 squared? -2 squared. -2 times -2 is +4. +4 times 4, 16. 16 minus 1, 15. -2 minus 16. -2 plus 16? Is it a straight line? No, can't be, can it? What would it look like, just for fun? Because you're going to graph a million of these in grade 11. Parabola. 0x, -1y. 2, 15, -2, 15. And it makes this fun U shape. It's called a parabola. Parabola.
How do you spell that?
Parabola. 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 Yeah, because they did this in grade 2. Grade 2. I said grade 3. Huh? Well, I couldn't decide how early I need to go with this. The Chinese kid that lives in my basement did the algebra that you guys do in grade 9 and grade 2. It shouldn't make you feel bad about yourself. It should make you feel bad about our education system. And when you get older, you should fight to change it. Because there ain't nothing different about a brain of a kid in China. They're just expected to do something, learn it, and move on. No. They do have more pressure, but that pressure is of their own making. If you guys were expected to learn something and move on, you could do it. You have the brain power to do it, but we don't do that. We teach you the same thing over and over and over and over, which is useless. Because when you get to something new, you're screwed. Right? When is your brain most receptive to learning? When it's younger. What do? Fill it with the same stuff for 7 years in a row. Grade 4 science is grade 10 science. It's exactly the same thing, except in grade 10, you're not just talking about chemical reactions like you were in grade 4. You're actually writing them out. Don't you think you could go that one step further in grade 4 when you're learning about it? Yeah. All right. That's another story for another day. We will talk about the Canadian education system many, many times over the next little while. Is that a straight line? Yeah. So is it linear? Yes. Why? Because here up to here is plus 1 over, what's that look like? About 2/3? Let's check this one. Down 1, does that look like it's over about 2/3? So it makes a straight line. Now this one causes people trouble. People get, not linear, Mr. Myers. I know, right? Of course this is linear. Why? Because when x changes by 1, y changes by 0. When x changes by 312, y changes by 0. The change is always the same, therefore it's a line. Everybody Gouda? Great! G. Yes or no? No. Of course not. It's curvy. Is it a function? Just for fun. Yeah, why? This one. Is it a function? Yeah. Okay, good. Just for fun. Oh, crap. I left yes there. Is this linear?
No.
Yes. Is it a function? Function? No. Why not? Because the vertical line will hit a whole lot of outputs, won't it?
Yes.
Infinite outputs. Because it is always, the only input is -2. Yeah? Yeah. Okay. Last thing you need to do is graph these two things. Now, guys, please listen to me. I don't know why what I'm about to do confuses people. But every year, people are like, how do you even do that, Mr. Myers? I don't get it. Make a table. So for A, the table must have X and Y, correct? X is our independent variable, which is also what? What is the other thing we call the independent variable? We call it the IV. We call it X. We call it the domain. We call it the, starts with an I, ends with a T, has input in the middle of it. Input. Okay? Now, input means something you put in there. Okay? This, I know, Antonio. So what I do is I say, okay, I'm going to put in some input. I'm going to put in -1, 0, 1. And the kids go, how do you know what to put in there, Mr. Myers? I never know what to put in. Oh my God. It doesn't matter. Put any numbers in. That's why it's input. Kids are like, I don't know how to start. Just pick 3 numbers. Why must I pick 3 numbers? To see if it makes a straight line. Because any 2 points can be joined, can't they? So what 3 numbers should I start with? Any damn ones you want. Okay? It is, thank you, Antonio. What's the one number you should always use? 0. Because 0 for x makes that disappear, doesn't it? So when x is 0, what's y? 4. When x is -1, what's y? 2. Because 2 times -1 is -2. -2 plus 4 is +2. When x is 1, what's y? 6. Thank goodness Antonio is here. Now, do I have x's and y's? Can I put them on my graph? I feel I don't need to review how to put these on a graph with you. Do I? Okay. Where is -1, 2 on the graph? I start at 0, 0, and where do I go? Go 1 where? 1 left and 2 up. Good. Where do I go for the next point? I start at 0. Do I go left or right? No. I go up how far? 1, 2, 3, 4. Then I go left or right, right 1, and up 6. Do they make a nice straight line? Yes. Do I connect them? Yes. Why? I can put any x in here and I will get an output. For every input you get an output, so you must connect the line. Because this is not a real life situation, is it? This is x's and y's. So I draw a straight line through them all. How far will that line go? Infinity. Right? And it will always be +1 to the right, +2 up. Or -1, -2. Right? Everybody good? All right. Now let's do the other one. X, Y. What are 3 good numbers to choose? 0. We should always use 0. What is 0 squared? 0 minus 3. This is tricky. 0 minus 1 trips some of you up. So, -3. All right, Abresia. That's why you're getting an A. What are 2 other numbers I could use? I could use 1. I could use 2. Could I use 7? Could I use 35? Exactly. The point is, who chooses? You do. There is no right or wrong answer. Mr. Myers, I never know what to input. It doesn't matter. I'm going to use 3. Now, I use -1 and 1. I've used 3. What should I use now? Notice I used 2 on, I used on either side of 0. What should I use now? I should use -3. Do I have to? No. So what is 3 squared? 9. What's 9 minus 3? 6. Yay! What's negative 3 squared? 9 minus 3? 6. Now I graph it. Oops. Where's my first dot go? I go to 0, and I go down 1, 2, 3, and I put a dot. Then I go out 1, 2, 3, and I go up 1, 2, 3, 4, 5, 6. And I go 1, 2, 3 to the left and up 6. And I make, oh, this funky shape again. Is it linear? No. Is it a function? Yes. Please look at the difference. Linear non-linear. What's the only difference between the two equations? One has an exponent. Okay? Linear relations can't have exponents. Got it? Excellent. You need to do, and I quote, page 308. Oops. And I have started making sure, just in case Mommy or Daddy want to know about homework, you'll notice the last little while I've been including it on the video. So when your parents call me and say, my kid never has homework, I can say, go watch the video. I know, right?